Yep.
Okay. So, system of linear equations we're discussing.
Yep.
First of all, if we talk about linear equation, how does the linear equation look like? So linear equation will look like this, like a1 x1 plus a2 x2 up to so on, and then a and x. So here x1, x2, and xn that I have written, these are all variables. Means this is linear equation in, like, if I write like a1 x1 plus a2 x2 plus a 3 x3, if I write. So this is linear equation in three variables, right?
Yeah.
Because x1, x2, x3 I have written. But if I write x1 plus a2 x2, so this will be linear equation in two variables, right? So
Got it.
and a1, a2, and an that I have written here. So these are coefficients for these variables, right? So coefficient means these will be a
Numbers.
constant value. It will be given to you, right? It might be equation might be given like this: 3x1 plus 4x2 plus 9x3, and this is further equal to b. What is b here? B is again a constant value, right? It will also be given to you that this is equal to 9 or 5, any value it can be, right? So when, see, when we have to solve this, so at most you will get these three variable equations only to solve, right? The one key point that we have to keep in our mind is whatever number of variables are given, same number of equations we need to solve.
Right.
If there are three variables in the equation, you will need three variables are there, so you will need three equations to solve. Right? Example, another example you can write. This is also an example of linear equation. X2 is equal to times root 6 minus x1 plus x3, right? Because we when we will rearrange, so we can write this like 2 root 6 minus 2x1 plus x3, or 2x1 plus x2 minus x3 is equal to root 6. So you can see this is of same form, right?
Yeah.
Now I will write one equation. You have to tell whether this equation is linear or
Linear.
not.
Okay.
Equation is 4x1 minus 5x2 equals x1 x2. Is this a linear equation?
Uh, yeah, it is linear.
It is not
Because
linear because it is in product.
oh, so
You,
basically, if the x power can increase or it's being multiplied, it can't be linear.
linear equation means the highest power will be 1 only,
Okay.
right? There it is x1 times x2. This we cannot write. One more equation I am writing, you have to tell whether it is linear or not. X2 is equal to root x1 minus 6. Is this a
It,
linear equation?
yeah.
This is again not linear because
But
it is root x1.
oh, root x. Okay. Oh, yeah,
Because
power is x one half.
because
Sorry.
it is the square root. So it is again not a linear equation, right? So this is one of the linear equation that I am writing. This is one of the linear equation that I have written, right? And when we say a system of linear equations, right? So this means we are talking about the collection of all these equations. Maybe I am talking about like 3x1 plus 4x2 plus 6x3 is equal 1, 4x2 plus 6x3 plus 3x1 equal 2, 6 uh, x3 plus 4x2 plus 3x1 is equal 6. So when I am talking about this whole set, all these three equations, then we will say okay, this is a system of linear equations, right? It is a collection of one or more linear equations involving the same variables. It must have same variables. Only then it will be a set of linear equations. Like if I write, let's say I'm writing 3x1 plus 4x2 plus 6 x3 is equal 0. And second equation I'm writing 6y1 plus 7y2 plus 8y3 is equal 1. So this is not a set of linear equations because variables are not same, right? Why
Yeah.
do we need to keep variable same here? Because here we will talk about the solution of the linear equation, right? So here we will talk about the solution, means all those numbers that will satisfy each equation, right?
Yeah.
Solution of the system. So whatever solution you will get, that solution or those values when we will substitute in x1, x2, x3 of all these three equations or two equations, these values will satisfy the equation, right? So this set of possible solution, set of all possible solutions is called solution set.
Okay.
We'll call this a solution set of the linear system, right? And if two set have same solution set, like two system are there, one is like, let's say a1 x1 plus a2 x2 plus a3 x3 is equal b. uh, a maybe a4 x1 a5 x2 plus a6 x3 is equal c. a7 x1 plus a8 x2 plus a9 x3 is equal d. This is one system. And another system of linear equations is b1 x1 plus b2 x2 plus b3 x3. This is equal, let's say, ki, a. Then we can write like b4 x1 plus b5 x2 b6 x3 is equal e, and b7 x1 plus b8 x2 plus b9 x3 is equal n. This is another, right? So let's say the solution set that we are finding here, they have same solution set. Let's say S1, S2, S3. These three numbers satisfy all these equations.
Yeah.
Satisfy this also, this also. In that case, we will say these two linear systems are equivalent. These two linear systems are equivalent if they have same solution set, right? मतलब each solution of first system is solution of second, and each solution of second is a solution of the first one. So there are multiple ways to find the solution. We can solve algebraically also, right? And we can solve graphically also. If I consider example the x1 minus 2x2 is equal minus 1, and minus x1 plus 3x2 is equal 3, right? If we plot a graph of these equations, right? If we plot graph of these equations, what type of graph will be there? So graph, if I draw for this, so it will be a straight line, right? With a positive slope, And when you will extend, so there will be a point where these lines, this should be a straight line. It is not looking straight. I have drawn rough, but when we will draw, so these two lines will intersect at a certain point, right? So this point of intersect is the solution of these two lines, right? So here, if I will get any value at this point, let's say I am getting value of 3 comma 4. So this 3 comma 4 will satisfy both of these equations, right? Any point. So this means that this point of intersection is the
Solution.
uh,
But
so
to
solution of
use
our
that.
linear system.
Okay.
So this is graphical method to solve the linear equation. So here you can see there is one point. So if there is only one point of intersection, we call it as exactly one solution. If it is a straight line, is it possible that there is more than one common point in case of straight line? Is it
Uh,
possible?
no, because once they pass, they can't meet again because it's not a quadratic.
It,
They'll meet once and keep going, continue going into infinity. They can't meet again and again.
but the possibility is कि if two lines coincide, let's say this is the first line and
Hmm.
second line also coincide,
Yeah, I mean, if it's on the same,
same line only, same points, when it will coincide, right? So that means, so if we look carefully, so how many situations do we have here? We will have three situations here. First situation is, I have drawn this line and I have drawn this line,
hmm.
right? One point of intersection.
But how can I have more than one? That I don't get.
That I will consider example with the equation when we will consider. We will see ki when it is coinciding.
What do you mean,
Two,
like overlapping over each other?
they will overlap with each other.
So then all the values are the solution, no?
Means equation you will consider, so it will satisfy. Example you consider uh, x1 plus x2 is equal 1. And second is 2x1 plus 2x2 is equal 2. I have
Yeah.
considered this equation. So in this, it look like two different equations,
Hmm.
right? But when you will uh, plot this on the graph, when you will substitute the points, so you will get same point that will satisfy these equations, right? For this, if I find which point can satisfy this equation, like if I take x is equal to 2 and x2 is equal minus 1, it will satisfy first equation.
Yeah.
And if I take this in second equation, I take x1 equal 2 and x2 equal minus 1. Is it satisfying or not? Check it. Are
Wait.
these two
Yeah.
points
Both are satisfied.
satisfied, na?
Yeah. Yeah. Both are satisfied.
So any points you can take that will satisfy the first equation, same points will satisfy the second equation also.
Oh, like that.
Mean there is not only one solution. There are infinitely many solutions,
Hmm.
right? So when there is one point of intersection, we say कि there is exactly one solution. And when it is case of coinciding, कि there is first line and second line is coinciding, right? Infinitely many solutions.
Yeah.
It will coincide. And third situation is the two lines that you have drawn, these are parallel lines. And we know that parallel lines will never meet. They will meet at infinity, theoretically, we say, but otherwise they will not meet, right? So if they will not meet, so how many solutions will be there? Zero. No solution. because solution is given by point of intersection or the point where lines are meeting. So they will not meet, so there will be no solution. So this is case of parallel line. And in parallel line, like how do we know that line is parallel? So in parallel lines, only constant will be different. X1 plus x2 equal 1. Second equation will be x1 plus x2 is equal 3. So this is case of parallel line. Right? Means if I compare this with general equation, what is
Mm.
general equation? A1 x1 plus A2 x2 is equal B.
Yes.
And then we can write like A3 x1 plus A4 x2 is equal C. Right? So here the coefficient ratio A1 by A3 is equal A2 by A4, but it is not equal B by C. So this is like condition. You will look at the equation and you can tell whether there will be solution of the equation or not. Did you get this?
Yeah.
Right. And in case of infinitely many solutions, as example I have considered here, if I compare this with the general equation, so what I can write? I can write that A1 by A3 is equal A2 by A4 is equal B by C. All three are equal, right? Ratio. This means that this has infinitely many solutions. So this is how just by looking at the equation we can tell whether equation will have solution or equation will not have any solution. Fine. Shall we move on next topic?
Sure.
So when there is one solution or infinite many solution, this situation we say कि a set of linear equation is consistent. Consistent, right? In this case, when we have solution, we say कि set of linear equation is consistent, right? And if there is no solution at all, we will say the set of the linear equation is inconsistent. Inconsistent means no solution, right? So case of parallel lines, the set will be inconsistent as it will have no solution. Fine.
Fine.
So one graphical method was there. We have seen how we can solve using graphical method, right? Now how to solve using the algebraic method, right? So using algebra when we have to solve, so what we can do is we use elimination method. Right? There are different method, elimination, substitution, different methods are there. If I consider equation in two variables, like x1 plus x2 is equal 1 and 3x1 plus 5x2 is equal to, this is given. Now, if I have to solve this, so what I can do is either I can make x1 as a subject, x1 is equal to 1 minus x2, then I will substitute here. So 3 times 1 minus x2 plus 5 times x2 equals to, so 3 minus 3x2 plus 5x2 equals to, right? So 2x2 is equal minus 1, x2 equal minus 1 by 2. Then you will substitute here, so you will get x1 is equal like 3 by 2. This is how we can solve, right? Uh, Second method, this is substitution method. We have substituted value. The second method you can use is elimination.
Hmm.
In elimination, what we do, we make constant same. Coefficients of any variable you can make same. Means here, if I want to make coefficient of x1 as same as the second equation, what I will do, I will multiply the first equation by 3. Now, if I multiply first equation by 3, what I will get? I will get 3x1 plus 3x2 is equal 3, right? And second equation is given 3x1 plus 5x2 is equal 2. Now what I can do, I can subtract these two equations.
So
So
this
when
is
I
just solving simultaneous equations.
simultaneous equation we are solving,
Okay, okay.
it will cancel out, and you will get that 2x2 is equal minus 1. Again, x2 is equal minus 1 by 2. Again, you can substitute in any equation and you can find the value of x1. Right? So there are two methods like substitution and elimination. The problem is ki, when we have uh, equation in three variables, then it is sometimes it is lengthy. Like we don't know how to solve this set. We struggle to solve. In that case, what we have to do is we have to start by elimination on. Right? Like I'll consider one example. So example is x1 minus 2x2 plus x3 equals 0. 2x2 minus 8x3 is equal 8. 5x1 minus 5x3 is equal 10. Right? So this equation is given. What we can do is you take any two equations. First you take like first and second equation, eliminate one variable. Fine. Then you take another two equation. Like let's say I am taking second and third equation. Eliminate same variable. Again, means let's say using first and second, you are eliminating x3, right? Then using second and third, again you will eliminate x3. So what will happen after eliminating x3? You will have equation with variables x1 and x2. Similarly, here you will have equation with variable x1 and x2. Now when you have now you will have equation with two variables, and you can solve either using substitution or you can eliminate. Fine. Example here, if I want to eliminate like x3 variable here, what I have to do is I will multiply the first equation by 8, right? So this is equation first, this is equation second, and this is equation third. So if I multiply equation 1 by 8, what I will get? 8x1 minus 16x2 plus 8x3 equals 0. And second equation I will write as it is. 2x2 minus 8x3 is equal 8. Now, if I want to eliminate x3, what I will do? I will add these equations. So when I will add these equations, on the right hand side, I will get 8. This will cancel out. So I will get
Hmm.
8x1 minus 14x2 is equal 8. This is our equation, right? In x1, x2. Now what I will do? Now I have to eliminate x3 again from the second and third. How can I eliminate x3? Can you tell? In equation second and third.
In second, third, C is already removed, no? Or you want me to make another equation again?
So
Wait,
what I can do, I can multiply first by
multiply by 40, make it 40. So times 8 times 5.
means second equation I will multiply by 5, and third equation I can multiply by 8, right? I will have 10x2 minus 40x3 is equal 40. And for second equation, I will have I multiply by 8, so 8 5 40 x1, and then minus 40 x3 is equal 80. Now what I will do, I will subtract these two equations. So when I will subtract these two equations, what I will get? 40x1 minus 10x2 is equal 40, right? So here I am having one equation in x1, x2. Here I am having second equation in x1, x2. Now I can solve these equations. Now again, you can do multiply this equation by 5. If I multiply this by 5, I will get 40x1 minus 70x2 is equal 40. And second equation I can write as it is 40x1 minus 10x2 is equal 40, right? So If I will subtract these two equations, so I will get like x2 value I will get 0 only, right? X2 I am getting 0. I can substitute here x2 as 0, so x1 I will get 1. Now x1 is 1, x2 is 0. I can substitute all any value in maybe in this equation. If I substitute x1 is 1, so I will get 5 minus 5x3 is equal 10. So 5x3 I will get minus 5, x3 I will get minus 1. This is how we can solve these equations. Is it fine?
Okay. Yep.
Now we can, after that, what we can do, we can substitute these values in any of the given equations to check whether our solution x1, x2, comma x3, that is 1, comma 0, comma minus 1 is satisfying or not. Like if I substitute in this, I will get 5x1 means 5 and minus 5 into minus 1 plus 5. So I'm getting 10, right? So after solving, we can substitute and then we can find whether our solution is correct or not. Fine,
Yep. Yep, fine.
right? So this is algebraic method. First, graphical method. This is algebraic method. Now there is one more notation in which we can write the equation. That is matrix notation. Matrix notation. So in matrix notation, how do we write? Like let's say equation is uh,
Done.
what?
Sir, I've never done matrices. Like, this
Matri-
is completely new.
Oh, you haven't done this?
Never. Like, not
Okay.
even in A levels.
Okay. So here, how do we represent? We'll consider any system of linear equation like x1 plus x2 plus x3 equal 1, x1 plus 2x2 plus 3x3 equal to uh, x1 plus 4x2 plus 7x3 is equal to 3. This is equation, right? In matrix notation, when we have to write, so first of all, so this is how we write matrix. We put these square brackets, and in square brackets, we write values. This is known as matrix notation. Now, which values we will write? We will write the coefficients. How do we write coefficients? Like, first of all, we will write for x1, then we will write for x2, then we will write for x3 in a particular column. Column wise, we have to write. First column for x1 coefficients. X1 coefficients are 1, 1, 1. Second column for x2 coefficients, and x2 coefficients 1, 2, 4. Third column for x3 coefficients, that is 1, 3, 7. So this is our matrix notation, right? So here the name of this matrix is coefficient matrix. Name of this matrix is coefficient matrix, right? Or you can say ki matrix of coefficients. And if we include constant term also, these constants also if we include, then in that case it becomes augmented matrix. Augmented matrix it becomes, right? Augmented matrix means 1, 1, 1, 1, 2, 4, 1, 3, 7, and then here 1, 2, 3. This is augmented matrix. This is coefficient matrix. Right? And if if any variable coefficient of any variable is missing, then how do we
Mm.
write? Let's say equation is given as x1 plus x2 equal 1, x2 plus x3 is equal to maybe 2x2 plus we call it 3, and then it is given as like 5x1 plus 7x3 is equal uh, 4, right? If this is given. Now, how many variables do we have? 3, right? Or
Okay.
2?
Here you have three variables.
We have three
Two
variables, right?
yeah, and they're not like in line. Like not all of them are there.
Uh, so how do we write for this is, first we know that the first column is for the coefficient of x1 variable. Now in the first equation coefficient is 3. In the second equation it is missing. Can I write it as 0 times x1?
Uh, you just maybe just write it zero because it's
Huh?
not present, right?
Because nothing is there means we can write na 0 x1. If x2 term is not there, we can write 0 x2. Here we can write 0 x3. So here it will become 0, 3, 0, 5, 1, 2, 0,
Hmm.
0, 1, 7, 1, 2, 4. So this is how we will write the augmented matrix here.
Okay.
Fine.
Wait,
So
this
yes,
four, right? Yeah, yeah, four. Oh, yeah, yeah, got it, got it.
got it.
In augmented, we also write the answer, right?
Constant value. We write the constant. This is not answer. This is not our solution.
I mean, like, what that thing is equal to, like the equation.
Is equal to means constant value we will write in augmented matrix. In coefficient matrix, we write only coefficients of the variables,
Okay.
right?
Got it.
So these are rows and these are columns, right? And whenever we have to write the size of a matrix, if I have to write size of matrix is given by the number of rows and columns, right? How many rows are there? 3.
Uh, three.
Column 4, right? So size of this matrix is 3 by 4. We read it as 3 by 4 only, right?
Yeah, it
And
will be three.
we will write it as 3 comma 3 like cross 4, and we will read it as 3 by 4. This is the size of this matrix,
Hmm.
right? Uh, Generally, we can say this M cross N we can write M by N, any rectangular matrix M by N. Okay?
Yeah,
Number of rows will always comes first,
first.
and M
So
and
also,
yes,
basically x-axis first and y-axis, kind of.
we
It's
can
like
say
in Python.
first rows, and then you can say X and Y also if you want to keep in your mind in this form. You can, right?
Yeah.
And M and N will always be a positive value, ठीक है? Or integer,
Yeah, yeah. There can't be negative rows.
or it can not be in fraction. M and N are positive integers, right? So